of India, which we know as Padma Shri. So I think this is all I have to say about Professor Rai. And I must say that I had met him last time in Delhi airport when I was setting up the Center of Excellence at NIT Durgapur. I had to frequently go to Delhi for several review meetings. One evening I met him in the airport with travel to India. It was 2016 and now I met him once again. So it's a real honor for me to introduce him, and I'm really eager to hear from all of you.
Just before that, we want to felicitate our Mr. So, as a token of love and respect, a small moment is given to our. Okay. Now the time for what we are waiting for, Professor Rai. Sir.
A very good morning to all the participants to this very important international conference on the application of natural science and engineering sciences in sustainable development. This is possibly one of the most important topics in today's context, and I must congratulate the organizers, the Department of Physics, and I find that you have got some two centers on spintronics and fiber optics. So that's a great thing associated with physics department of this great university. So at the outset, I must say that in a very short span, your university, the faculty members, the students, everybody, you have done commendably well. And so many departments have been started, and the researchers out here and in other universities also, they are doing very well. Now, so far as sustainability is concerned, I mean, all of us, we have got some kind of a, idea about what sustainability is. Sustainability concept was there maybe that, as Honorable Vice Chancellor was just mentioning, from time immemorial. And but then it's very interesting that for the first time in writing, the whole concept of sustainability came in the form of a report by the chief of, the section mineral company. They were doing the mining company. They were doing the mining, and during the process of mining, coal mining in England, they had to cut off a lot of trees. So he, for the first time, found that the total number of trees we are cutting off, and if we do not replant accordingly, then what will happen after maybe 5 years, after 10 years and all. So a very interesting thing, which was for the first time in writing, a report was prepared by the chief of that organization, and it was exactly 300 years back. Today it is 2024, it was in the year 1724. It's interesting, the concept was there, but then how the entire environment will be truly depleted until unless the reproduction, the regeneration, the replantation is done in a much bigger, with a much bigger vigor compared to whatever we are depleting. The trees are being uprooted, but then you have to, and you know that today if you cut one tree, then you have to replant, say, 5 trees, which is so important today. Why it was on trees? Because those days in 16th, 17th, 18th, 19th century, and even today, not only from environmental point of view, those days The whole economy was based on wood and forest-based economy, agroeconomy and forest-based economy, 16th, 17th, 18th century. So man, for its own necessity, has continuously done quite a lot to really ensure the concept of sustainability. So this is about a little bit of things. Whenever, Professor uh, Devashish Banerjee, your Vice Chancellor, so during his speech, he talked about a particular book, and that is written by Rachel, Carson. Please read that book, The Silent Spring. You will find a beautiful book from literature point of view and also from scientific point of view and on the environmental degradation because of use of so much of DDT for production of more, food stuff. In America, they were using DDT like anything, even in India also. The book came up in 1962 and it had shaken the minds of not only the Americans, in America, in Europe, throughout 60s. The Silent Spring was possibly for several years was the bestseller. So that book is still available. Please try to, as students, you should read that book and see how the spring was silenced, and a small kid coming back from the school, he tells his mother that, mother, I cannot find. এটা অনেকটা ওই বিভূতিভূষণের পথের পাঁচালীতে দেখবে যে সেই অপুর যেন ছোট্টবেলাকার কথা বলছে যে কোনো স্প্রিং নেই তো এখন, সেই যে রবিনস ব্লু, রবিন পাখিগুলো উধাও হয়ে গেছে, মাছগুলো যেগুলো ভেসে উঠছে সব মরা মাছ, and how the environment has been degraded by that. So this is one of the important things. Now these are all past things and old things. Let's come to the actual thing, and that is how the environmental degradation and sustainability can be understood. We are living in a space of oceans. One of them is oceans of electromagnetic waves. Those of you who are students of physics, you know that we are living truly everywhere you see is wave and wave and wave. You should read another book which was written exactly in 1937, almost 90 years back, by Gurudev Rabindranath Thakur, and that is in Bengali known as Bishwa Porichoy. And you will find that on wave and on electromagnetic wave, how it pervades the whole universe, and the basic principles of electromagnetics, which was given by none other than those of you who are in physics. You know about Maxwell's field equations. Every student of MSc Physics must understand the basic principles of Maxwell's field equations before you get a degree, isn't it? So it is that the whole concept of communication, signals, everything is based on. In fact, light itself is an electromagnetic wave. And imagine that these are all in 1860s and 70s. And then based on all these concepts, not in the environmental point of view, but our Sir J.C. Bose, he for the first time developed a particular, in a frequency, we call it as millimetric wave. He not only generated the wave, but then he showed, practically demonstrated that this kind of waves can propagate in free air without any wear. And then he developed the first galena-based, that is a semiconductor-based detector for detection of the signal, which was generated from one room. The signal propagates in free air, and then it is detected by a galena-based detector. Please go through, again, another very important publication You can see it even in the net. You can get the original papers in a conference proceedings of 1997 IEEE special issue on wireless communication. So please, the students, since I came to know that most of you are from students of physics, so you have to read that. Now we are truly living in a space of electromagnetics. More importantly, we are living in a space of microbes. I had to spend some time uh, for understanding the whole issue of the ocean of microbes. It's very interesting. Our vice chancellor was mentioning about how, in fact, in that Silent Spring also, the author writes about how the soil has been degraded by the different pesticides. And do you know that how many different varieties of microbes are there in our soil? I do not know whether you have got a biological science department or you have got a civil engineering department or whatever it may be. Even the physicists also can take up this kind of a job. That is, just have your own soil and then test it about the presence of the different microbes. How do you know that what are the microbes? For that, like say human beings, we have got a genetic structure, the bioinformatics. Your registrar himself is a bioinformatics PhD, and it's very interesting that there is a genetic structure of the microbes also, and these are known as the different kinds of microbes which are present in the soil. If you can do little bit of studies, a grand studies was first made here in Calcutta by none other than one of the leading women scientists of India, Professor Ashima Chattopadhyay. You all should know her name and her great contributions. She received DSc in 1940s, much before our country got independence. And she spent her time days in understanding the different spaces of microbes. And whatever we see today, many of the diseases are becoming, antibiotic resistant. That is because we have been consuming antibiotics to a very large extent for several decades. And now TB is again resurfacing, and they have become antibiotic resistant. Lots of diseases, you take so much of antibiotics. So take care before any operation takes place. And it becomes there are different types of varieties of, such kinds of infections which are there everywhere. So people say that get rid of infections. Infections are now more dangerous than any of the, even it is as dangerous as a nuclear weapon. It's dangerous, infection. And much of the death, it occurs in the hospitals and all because of infections, not because of surgery. Surgery is fine, but then the patient dies because of infection. So the metagenomics, as it is called, please make sure that you understand that there is a genomic structure of each one of these. And then, since there is a combination of such huge varieties of, the infection, the microbes and all, so you can have a genomic structure of that. It is known as metagenomics. And sequencing that genome structure, I'm very happy that we could purchase one of the first the gene sequencing machines in the eastern part of India immediately after I started my new institute. And it is in the private sector. I decided not to join any government sector which has become too much political. Tried to get rid of all these things. It's all being funded by private sector. I told them that the condition is we must get a gene sequencing machine. And we got it. The owner, they gave me more than 1.2 crores of rupees. And then we are now doing a lot of gene sequencing, not only the human gene, but then the metagenomic sequencing of the different kinds of certified. We are going to the hospitals, collecting the samples, trying to find out that what are the genomic structures of the different microbes. So which is so important. You can do it for the soils also. Much of these microbes are good microbes. Much of the microbes that we have got in our intestine, inside us, are very good. They are friendly microbes. By taking more of antibiotics, we are even killing those good microbes, which are friendly microbes. So, understanding what is meant by the whole issue of sustainability, that is understanding. If you do not understand that what is this whole metagenomic world, ocean, you will not be able to solve the problem of tomorrow's, the whole issue of tomorrow's, sustainability. The second important thing is we are living in an ocean of data. Now we talk about the sustainability of environment, and before we go to the data, we need different types of sensing devices. As students of physics, you should know that the sensor is the most important thing, whether it is a physical sensor, chemical sensor. It's a sensor which can sense the different mechanical properties, not only in a macro sense, but in the nanostructure mechanical properties. So it's very interesting. The surface properties, the surface chemistry. So that way it becomes a combination of physics, chemistry, and biology. So it's very interesting. It's a combination. So we talk about, we have got so many departments, but remember that today it's all interdisciplinary. The whole thing is now coming to a single thing of knowledge. So knowledge is not partitioned, but we are partitioning them externally to make more concentrated kind of activities and understanding. But remember that everything is connected by a thread, and keep that interdisciplinary or cross-disciplinary, that concept with you, which is so important. Now, sensing means it's a very, very difficult and a different kind of thing. Sensing what? Sensing the environmental parameters. One of them is very simple. You can always make the sensors like, say, whether it is your temperature, humidity, the relative humidity. I think that you have got some of the equipments. Now, for example, if I ask you that, can you make a device which can give you the solar irradiance, the radiation falling on the surface of Asansol or Pure University? So I think that it is very important that you should know the solar irradiance, how much amount of radiation is incident on the surface. Now this radiation, the solar radiation, it is important to understand that it is not in one frequency only. It is in from ultraviolet to infrared, from say 200 nanometer to about not only just near infrared, but near infrared, far infrared, thermal. So much of components of the solar radiance is there, radiation. So please try to find out that what is the solar spectral characteristics. And being physics students, I had to remodel, because I thought that what to speak in this conference, I thought that for physics students it's very important to understand that what is the spectral characteristics, because it is important to understand, because many times you will be knowing that we are using the solar PV. In fact, after I joined Shipur Engineering College, which is the second oldest engineering institution in India, only after Roorkee, much before the IITs were born, 100 years senior to IITs. So this Hipur, there we thought that we must go for renewable energy. So solar, we were not only using the solar panels, but I spent all my energy in ensuring that we get enough of funds in developing the solar cells. You can go to IST Shibpur, and our green energy center is one of the largest. 65 crores worth of government funding we got, and we were developing the solar photovoltaic cells and mainly the silicon cells. And you can just see there the different, I cannot, because it will take a lot of time to tell you that how a cell is made and how from individual cells you can make a complete solar panel. But to make it important, as you know that as renewable energy is the most important thing. This single sentence is known to everybody because energy gives you all the problems so far as the sustainability of the environment is concerned. But more importantly, you have to know that how these cells are made. It's only here in Howrah. Go there and then I can arrange for you to visit that place and see. It was a big effort on my part. And then we had started just from scratch, from zero, to a big center of excellence on green energy. Now, what we found was that, many people, they say that these panels which are kept, for example, here in Asansol also you may be having many such solar panels, and after some time it becomes, it doesn't work. Why? Because of dust. One of the things is dust. But then you can work on, these are all research topics. Can you make a self-cleaning solar panel? For sustainability, it has to be sustainable. Na? Today you are having a solar panel. So those who are researchers in physics department, you should know that how you can make it sustainable. You have to then make, because every day, especially in India, you cannot ensure that the person will clean the whole thing. Dust cleaning is not done. Even you know that in your university also there are people, but then they don't work. Everywhere, this is the continuous. So, as a physicist, you should know that how to make the dust cleaning device auto dust cleaning. You don't need any human being. You don't need any person for dust cleaning. But it's very important also to understand. We did this experiment in IST Hippo, and we found is very interesting that the part of the ultraviolet radiation, almost 200, 300, 350 nanometer, that range, ultraviolet radiation itself also deteriorates. It degrades the solar cells, the panels. Over years, the functionality will degrade. So try to see some of the papers which talk about the effect of ultraviolets on the solar PV, because you are having some kind of an center also out here. So please do these kind of things. In Shibpur, what else we did, which you can always replicate here in your university, we had a microgrid. And since the topic says that science and engineering, it goes hand in hand. There is no concept of engineering without science. So what we did was, we made a microgrid. Microgrid means we had about say 20 kilowatts of solar panel, 1 kilowatt hour. We were not getting any wind. Even in Howrah, the college is located, the IST institute is located just near the Ganga, the Ganges. But then we did not get more than 1 kilowatt. No wind, no. So, but then you can try here. I do not know in Asansol whether you will get it. But most importantly, have a biomass related, one biomass digester that can give you, I can tell you, I haven't seen your university, but from the hostels, if you can take all those, food stuff rotten food stuff and whatever the students are wasting, waste products from the markets. I found Asansol is a big market. Take all the waste stuff. Our municipality chairman is here, Mr. Banerjee, so he can also help you. And then make a biomass digester, big digester. Now these three sources of energy, solar, wind, biomass, because here there is no hydel energy. Now these three energies, give it to a local grid, do not give to a online grid. But then you can prepare your local grid so that it can be microgrid, smart microgrid. I do not know whether you have got an electronics or electrical department, but make it smart so that only when solar will not generate any power at night. So, and for maybe several days it may be cloudy, you may not get enough of power from the solar. What do you do then? You also have to get one very important thing, which is a battery charger. Please, this battery technology, this is the most important technology so far as sustainability is concerned today. And battery technology, there is not only in the micro level, at the different kinds of vehicular battery. It's not only just the lithium-ion battery. As a student of physics, you can also think about, say, sodium-ion battery. You can also think about the multiple other options. And there comes the whole concept of the alternatives to lithium-ion, because it's all about research, because sustainability will come only through the different modes of research that you will be doing. So if you can do some good kind of investigation on this, and battery charging, that is very, very important. This is one of the major things which a lot of companies in USA, because every year I have to spend at least say 3-4 months out there in United States. Suppose in Detroit, a lot of companies there, the automobile companies, they were spending huge amount of money for having the different kinds of renewable, whether the energy will come from hydrogen or from this kind of devices like, say, lithium-ion or sodium-ion or whatever it may be. So it's interesting that, okay, you have to have that, but more importantly, in a country like India, you must have a smart grid, but the grid should be such that when there is no solar energy, then from the biomass digester, the energy that you are generating should go to the things. So in our country, there was an old saying that make it small, distributed. Small and distributed is beauty, not the big ones. If the whole country goes to one Adani, the country will be devastated tomorrow. Make rather millions of smaller units. Make it distributed. More distributed they are, the better stable they will be. It's very interesting. The stability will be more, and connect them by AI, artificial intelligence. So here comes again another important concept. That is, without this concept, no science and engineering can proceed today. I will end my talk with AI and machine learning. We have been doing, because that was my original work, which I had the opportunity to even deliver lectures from 1980s to IIT Kharagpur, including in Sundar Pichai also was my student at IIT Kharagpur. So now they are the people who in the entire Silicon, the Bay Area, Silicon Valley, they are the persons who are controlling the entire IT revolution, not only in America, but in the whole world. Now there are 2-3 things. One is very, very important thing. Please remember that AI is one of the enablers of the 17 goals of sustainability. You should read because you are doing this conference, you should read the 17 goals of sustainability which United Nations has talked about. Sustainability goals. That means with that, to make anything sustainable, what should be the properties in healthcare, in environment, in people, in society, even the humanities people are also involved here, in economics. Everything is a part of sustainability. So, whatever you are doing, in the olden days, they used to say that the local resources should be used locally. Otherwise, what will happen is if you have to have transportation of the resources from another part, then it will be leading to more of transportation cost, which will generate more of greenhouse gases. So the whole thing requires more of AI applications in the resource distribution, the resource generation, and in the engineering area, in management, we call it as how to really resource mobilization, because in COVID time we have seen that transportation was a big problem. So please know one thing, that AI has got artificial intelligence and machine learning, especially the more recent ones, that is the generative learning and large language model. Many people may say that these LLMs, large language models, what it has got to do with sustainability? You should ask such questions. They have got also a computer science department. So the phases should ask these questions to your computer science students, that what is the role of LLM, that is in AI, in sustainability? It has got a huge role to play. And not all the things are positive. There are some bad things also in AI, like in any advanced technology. So you have to take care, and most of it, the regulating authorities, they should understand. Unless they understand, some of the bad things of AI may also creep in, and they will be dangerous for the sustainability things. But generally, let us be very optimistic, and let us apply the artificial intelligence and machine learning. Maybe that this is not the forum, but then we can discuss it at some other later times, that how a physicist will require such kinds of optimization and AI and machine learning in solving many of the truly vexing problems. Suppose even when you are working with say uh, with say um, laser technology, the photonics, the biophotonics. I'm sure that some of you in physics department, you are having it. Finally, whatever you do, you have to optimize it, and for that you need a special optimization technique. I would request the professors of physics here to please ensure that you teach one subject on optimization theory. That is very important. We have got from NIT Durgapur my colleague, and they can also help you. Optimization is very important subject for engineering and also for science, because tomorrow's sustainability problem, everything has to be optimally allocated. So it will become, and it has already become, of paramount importance. So there are, huge area, because the space of microbes, energy, data science, everything encompasses a huge area. And that's what I personally feel, is understanding these oceans is the most important and challenging things. It may not fetch you a lot of papers. Papers are not everything in life. Although unfortunately that's what has been made. But understanding is most important. As students, please ensure that you understand this whole thing, whatever you are, because in one life you cannot understand everything from the different spaces. But at least in your own area of research, understand, keep on asking questions, Because tomorrow, whether civilization, humanity will exist or not, it's a big question. Whether we'll see the 22nd century or not is a big question. And many of the skeptics, scientists, I have heard in the United States, lot of people, lot of geologists, lot of environmentalists. So they have given through many of their talks, they keep on saying that the negative impact, please, every country head must understand that it's not only sustainability, greenhouse gases, the temperature reduction, the need to reduce the temperature, which is just absolutely, even after the latest, the convention, we are now quite off the track. All the countries, including India, we are not keeping our words. Hardly those countries which are, no, sorry. In fact, I've been given a warning bell. Okay, so I will not take much of your time, but I wish that this whole conference to be a grand success. Thank you very, very much.